Events are similar to RPCs with a few differences. They can be sent both reliably and unreliably. In addition, events can be received on any object which is listening for events, where RPCs are only received on the object sending the RPC. To demonstrate this, I'm going to use a sprite and then change the colors over the network. So I'm going to create a new 2D object in my game scene, a sprite. I'm just going to name it RaiseEvent. I'm going to set the scale to 15 by 15. And it's not visible yet because I haven't assigned a sprite. So I'm just going to click the circle in the inspector, and I'm going to choose any default sprite that has white in it just so I can see it. Alright, so that looks fine. I can see it's plenty visible in the camera view, and I'll work with that. So now I need to make a new script. I'm going to make a new folder, my scripts folder. I'm going to call it single use. This is just going to be a collection of scripts where I'm not necessarily tying them into anything. I'm going to make a new script. I'm going to call it RaiseEvent example. And then I'm going to drop that onto my RaiseEvent sprite. There we go. And since this object will be sending messages over the network, I need to add a Photon view component. So go ahead and select the RaiseEvent object and add your Photon view component. And you don't need to observe anything at this time. Once that's added, go ahead and open up the RaiseEvent example script. The first thing I'm going to do is set up the color changing and make sure it works locally. So I need to have a reference to my sprite renderer. So I'm going to do private sprite renderer underscore sprite renderer, and that's going to be the component. So private void awake underscore sprite renderer equals get component sprite renderer. And now I'm going to make a new method which will change the color on that. So I'll do private void change color. Then I'm going to do float r equals random.range 0f1f. I'm going to do the same thing, so I'm going to copy this and just change it to G and then B. And then I'm going to do underscore sprite render dot color equals new color R G B, and I'm going to use 1f as the alpha. Now I need to assign this whenever I press the hotkey. So I'm going to go ahead and go under update, and I'm going to do if input.getKey. Let's just say the spacebar will probably be fine. Change color. All right, so save my script, and I'm going to go back to Unity. Going to hit play and then hit spacebar once it loads up. Well, that thing is flying, isn't it? So I should probably change it to on key down, not when key is held. But it does appear to be working. So let me go make that change real quick. Going to change get key to get key down. I only want to be able to change the color of the sprite if I'm the owner of this object on the network. So at the end of mono behavior, I'm going to add pun and then press control period to quickly get to the using Photon pun namespace. That lets me access the Photon view in the object quickly without getting the get component. And then under the update where I check for the key down, I'm also going to do if base.photonview.isMine. And as you can see, it says true, the Photon view is mine and can be controlled by this client. That's essentially the same thing as saying it's the owner of the object. This is about ready for testing. In one of my previous videos, I said I was going to disable the feature where each client has to ready up before the lobby could start, and I actually forgot to do that. So I'm going to do that real quick. I believe it was class player list, I want to say menu. Player listings menu. There it is. So go ahead and open that class up and then scroll down quite a bit. And right here under on click start game, where we check the entries if they're ready, go ahead and select the for loop and then comment it out. I did that by highlighting everything, holding control, pressing K, and then holding Control and pressing C. Now I'm going to jump back over to my RaiseEvent example, and under where I change color, this is where I'm going to send the event. So I'm just going to hit return a couple times and open up some space. The first thing I'm going to do is create an array that holds the data. So I'm going to do object type. It's going to be an array. Datas equals new object. And I'm going to pass in R, G, and B. You have to use an object type because unlike RPCs, you can't specify what types are coming in. So you're going to pass everything in as an object, and then you're just going to cast it whenever you receive the event. Now I'm going to send the event, so I'm going to do Photon network.RaiseEvent, and the event code is a unique identifier for the event. You can use event code 0 through 199. The last 50 of the byte are reserved for Photon itself, so you're limited to at most 200 events. And I'd recommend using constants so you can pass them in as strings. For example, let me just go up here. I'm going to do private const byte. We'll just say color change event, and I'm going to set the code to 0. And then under RaiseEvent, I'm going to type in color change event. That way I can't mistake it for something else later and mess it up. And now I'm going to pass in my data. So datas. And you have RaiseEvent options, and I'm going to use default. Now you have quite a few options to choose from. This is such as whether it's cached on the server or not, what group it goes to, target actors, receivers, basically all of this under the API. So when you start using events, read all this and get an idea of what you can do with it first. Next, you have send options. And that's using exitgames.client.photon, and reliable and unreliable as your options. Like I mentioned, I don't care if these particular actions get dropped, so I'm going to use unreliable. One thing to keep in mind, the difference between RPCs and events is not just whether they're reliable or unreliable, but is what objects they're executed on. So if I have two objects in my scene, let's just call them object A and object B. If I send an RPC on object A over the network, then the other client or whoever I send it to are also going to get that RPC on object A. However, if I send an event over the network on object A, and object B is also subscribed to events, which I'll cover in just a moment, they're both going to get the event. So if you want to create the behavior of an RPC, but also send it unreliably, you might want to pass in the Photon view ID into the datas, something like this perhaps. So I do base.photonview.viewID, and then when you process the event, you'll check and make sure that the ID matches that on the object receiving the event, and only process it if it does. So now we need to make a method that is called whenever we receive an event. And to do that, we're going to actually listen for when an event is dispatched by Photon. So I'm going to do that under onEnable. So I would do private void onEnable Photon network dot networking client event received plus equals, and I'm going to press tab so that it generates the method for me. And now I'm going to do the same thing for onDisable, except I'm going to remove the listener. So I'm actually just going to copy my onEnable method, paste it below, and change it to onDisable. And then I'm going to add the minus sign next to the networking client underscore event received, rather than the positive sign. This ensures that events won't fire on this object when it's disabled. If you want events to always fire on the object, whether it's enabled or not, you would probably just listen for event changes on awake and not change it afterwards. Except on destroy, of course. You would want to unsubscribe when the object is destroyed. Now I'm going to go down to the method that's called, clear out this throw, And I'm going to do if obj.code equals color underscore change event, and then handle some logic here. This basically indicates that if the event code coming in is one for change color, then we're going to process the change color. This is important because you can receive event codes for other events that aren't even related to the method. So it's very important that you check and compare the code. So now I need to get the data that was passed in as the object. So I'm going to do object as an array, data. Actually, I'll do data for consistency, equals ob.custom data. And I need to cast this to the object array type. And we should be good. And now I can pull the RGB values from this. So just to make everything clear and easy to understand, I'm going to do every grab on a new line. So I'm going to do float r equals float to cast to a float. Data's 0. And I'm going to copy this and paste it twice. And I'm going to do G and then B and then change it to a 1 and a 2, basically very similar to what we have down here. And I'm going to take this underscore sprite renderer.color line and then paste it right below and set it to our RGB values. The code should be good to go at this point, so I'm going to go ahead and save everything, then head back to Unity. I'm going to make a build and test this out. If you want to do a build on your end, go ahead and pause the video and do so. I have a build made. Now I'm going to go to my rooms scene and I'm going to hit play. And then I'm going to go to the builds, hit play, or start that one up as well. I'm going to create a room on the build and then join it on Unity. And then going back to the build, I'm just going to start the room up. So if I go over to Unity and I press space to try and change the sprite, it's not going to work. That's because the ownership of this object belongs to the scene, which means it belongs to the master client. And as we mentioned earlier, the master client to start is whoever creates the room. So if I go over to the executable and I hit space, I should see it change color. And you can see that the event is working because it's changing across the network as well.